first red to the second red.
From the blue to the first red?
No, the first red to the second red.
First red to second red. So I took, so this cosine right here is this cosine. Okay, that didn't change. And then this 1 minus sine squared is cosine. Do you see it? With all of that circling and line drawing. Made it so much clearer. Okay, I'm going to erase that and do it a completely different way. Okay?
Wait.
Yes.
How do you go from the second red to the red?
I factored out a cosine.
You do the graph.
And that leaves me with cosine plus 1.
Oh.
Did anybody do the second
one? So I factored out a cosine. So cosine squared divided by cosine is cosine. Cosine divided by cosine is okay. All right, guys, let me do it a totally different way. One way is not necessarily better than the other. They're just different.
What did you do?
I got it right, but at what cost?
What did you do?
All right, guys, you could change sine squared into 1 minus cosine squared.
That's what I did, and then I just did the same thing I did the rest of it.
Then you factor, it's 1 minus cosine, 1 plus cosine.
Wait.
I guess.
You can't just cross things out from the last step. Okay?
I want to snap this.
Nope. So sine squared is 1 minus cosine squared. Okay. Difference of squares factored. Like x squared minus 4.
Oh.
Yeah. Yeah. So then turns into this, then we can cancel these out, and then you just have to be careful with distributing your
So
negatives.
1 minus cosine, always just like
1 minus cosine 1. Yep. Difference of squares. Then you don't have to write this, but just to show you, you need to distribute that negative, so it's 1 minus 1 plus cosine, which will just leave you with cosine.
yeah, I like that.
It's good stuff, yeah. I think it's a little easier than the common denominator, but
Until I commented about
Is this
it.
going better or worse than the rest?
pretty much how I expected. Yeah. Either it'd be a little, be a little rough. All right, second one here.
Stop.
I mean, you got there now.
No.
You rested over.
I'm joking. I don't actually do that. I'm joking. The difference of squares.
Okay, that's how I did it.
When you separated the sign.
He's like, I might be dumb. I was honestly.
Exactly.
That is not how I would have been. How did I do it?
You
Oh, I found common denominator and I just turned it into.
You could do that.
But like,
There's always one way.
Whatever you think fastest.
As long as you aren't breaking
And
any
whoa.
rules. All right, I factored difference of squares to get there.
Just find common denominator at that point.
Now you have a common denominator. What?
Yeah, I'd rather just multiply.
That was X. Search it up right now.
We just found common denominator and just ran out.
So you multiply by tangent squared and secant theta minus 1. That's fine. Yeah. You'll still get there. Lots of ways to get there. I'm probably more comfortable with the Pythagorean identities. Like, my brain just sees those right away. You guys are like, nope, not what we see.
I just see fractions and I'm like, make them the same.
That's fair. That's
Figure it out from there.
absolutely a good approach.
Let's say this.
As for graphing, that's a
Yeah, we'll get to graphing here in a
That's
second.
another crisis. One flyer at a time is tired.
Well,
I can't do many things.
all right, guys, questions on 2? Or shall I go to the graph
So
that
these
we're
are
all...
math businesses. It's like a hill takes apart. I
What
we not learned how to graph.
We did. It was like a month ago. This is from the last test.
First off,
So I did tangent squared, I turned it into Pythagorean
Sine goes like this.
I had to check.
difference squared, so I factored.
No.
Yes.
Oh my God.
Yes, you could have found common denominators.
Oh, I got it. I got it.
Look,
Sure.
Then I got it here.
I'm building a
secant sine and sine.
What?
You see David in that hoodie a lot.
I honestly don't know this guy's very.
Yeah, I know. I feel like it's the only thing I've ever seen him play.
He has a shirt on.
You got it. You got the answer.
Well, you can't.
What does your graph look like?
Yes.
Oh, I'm not done yet.
Okay. I don't know. Do I want to go 1 over cosine? No.
That's how I, wait, no.
That's what it looks like if you do a common denominator. I don't like it as much this way.
See, I did that, but I, like,
Yeah, I can.
That was far.
why did I do that? I factored out the secant minus 1 to get secant squared
Oh, you multiply
minus
that
1,
out.
and then I got tangent. And
So,
then
yeah,
tangent
you
squared
can
minus
do
tangent
this.
squared. Oh, yeah, I did. That's it, I did. Because
Because this is going to end up being secant squared minus 1, which is tangent squared.
Because I did the secant squared. I didn't write it out like that. I just did
You
it.
just multiplied, yeah.
Just a lady.
Yeah.
Once you have the first red thing, can't you cross out tangent square?
No. It has to be a factor of the numerator, which it is eventually. Like now it is.
A long time ago.
Can we like make a
Oh,
visual
it's
to
like
change
your words.
advisory from 4th to 6th period? No.
Oh.
Really not like our.
Oh,
So, what is secant theta minus 1 times secant theta plus 1? I didn't write it, I should have written
I'm not the one in charge.
it. Secant squared minus 1.
I just left.
Secant squared minus 1 is 2.
You'd rather have
What-
one of these sides than what you see square plus one.
That's right.
I wouldn't rather have lunch.
Multiply them out, and you get secant squared minus 1.
I
But I
did
think
it.
I'd
Much longer way of just.
later in the day.
I was
Then you can factor out the tangent squared.
I'm still like.
But you can't cross out this tangent squared or this tangent squared.
And how'd you go from
I factored a tangent squared out of both of these, which left me with secant minus 1,
Okay, found this door.
and then it all cancels.
I feel like
Yeah.
I'm so much.
But like it's
I feel like it's breaking your meters.
One, right?
I have no idea. It's so hot in here.
I messed up. Is your bottommost 3?
What was your question on the other way? Because we got to get to notes too.
Multiply by 3.
Let's see. We'll go back.
Then your bottom must be 2, no?
I knew we'd spend a while.
Nope, I'm done. Don't mind me.
There you
Sometimes.
go.
Cute.
Just all of it. All right, I'm gonna start graphing, guys.
What a beautiful word.
I love when it goes off to the chart.
Wait, yeah, that's not what I got.
Mine was pretty easy. I just had,
I had to put a whole new
And then eventually I was like, wait.
Mine's a 3. Well, hi.
Just say that you forgot, Sean, it's been 2 weeks.
See, but I have my whole liver this year. So I'll just straight.
All right, guys, on your graph here, what is the period of this graph? I. So your labels would be pi
No, we got that far. No.
Testing a bunch of
Good.
people.
Oh, okay.
Just lying.
For what? All right, so I have to think about parent graph of sine. Do that in green. Stretched by 2. Everybody okay with why I'm doing sine? Okay, we remember?
Can you stop for 1 second?
1.
Just say that you're go all the way back. Go all the way back. Come.
I'd rather prove. I love proving.
Just to say that.
This,
Yeah.
we should just let's just do each other's. When I have to graph, I'll give it to you, and then when you have to prove, just give it to me. And if I'm
Yeah, Finn, go ahead.
Are they one marks? Yeah. Basically one. And then I had to take a left.
Because they have the same denominator then? Yeah. Yeah. Yep. All right, guys, then our shifting here. We are going to the right by pi over 2 and up 1. How far is pi over 2? 2. Okay, so 2 tick marks? Yes. So over to the shifting? Yes.
I'm wearing a t-shirt. And I'm just
Okay, then I'm not going to graph sine, I'm going to graph cosecant. So the midline points give me asymptotes. You can draw in the sine curve if it makes you feel better. Yeah, open all the windows. No.
their classrooms are either really hot or really cold.
No.
There is a
All right, guys, there's your graph. How'd we do?
I give up.
The period?
Through graphing.
No, I know that. I don't know why.
Do you know what B is?
Love it. Great.
So you do 2 pi divided by B. C is this coefficient on X.
Oh.
Okay.
I did some online.
Oh, that's that.
Yes.
I thought the original one was fine. I was like, how did you get the?
Oh, yeah, like, why are you drawing all of those things? It's okay.
That's great.
That's something I want to.
All right, ready for notes, guys? Anybody questions on the graph before I change the slide? Yes.
This thing.
What is what? Double and half angles.
Angles.
Thank you.
I think we can go back to whatever we just
We can do it, guys.
I just want proofs this way.
No. Yeah. Double. Half angle.
You're getting wrecked and
Oh no, it's 6.3, not 6.6.
I think it's 6.3. I had to look. I was like, I don't remember what number we're on today.
I just flipped the two numbers. That's too early.
Miss Billy, are these easy?
Most of it.
So no.
No, most of it is. There's one part. No, like you guys, I tell you when it's not easy.
I don't have
Yeah, no, when I answer that, I answer it from your perspective, not from my perspective.
It's hard.
All right, guys. We have to create some formulas here. So sine of 2 theta, that's the double angle. We are doubling the angle, the theta. Okay. So we're going to figure out the formula by, that's not a 20. Would you agree that sine of 2 theta is the same as sine of theta plus theta? Yeah, we're on board with that. Okay.
All right. Okay. Woo! Do that. Got it. Right, yeah, that's it.
We're good. We're done.
Wrapping up for the day.
Okay. So, I'm guessing you don't remember your sum and difference formulas from before break. We had a formula for like sine of A plus B. Okay. We're going to use that, but instead of A and B, it's all thetas. So it's going to be sine of theta, cosine of theta, plus cosine theta.
Do you have to memorize these?
Yes.
Are those two things the same thing?
What do you mean? What two things?
Sine of theta plus theta and sine of theta cosine of theta plus cosine of theta.
Yes. Remember our formulas from before break, like sine of A plus C?
Yeah.
So it's like sine of A, cosine of B, plus
Oh, the
cosine.
sine of theta.
Yes. We're using that. Okay. Now, guys, would you also agree that this is just two of these? 2 sine theta, cosine theta. Okay, that is your formula for sine of 2 theta.
Ew. This is too many things to remember.
So you don't have to like prove it every time, but that's where the formula comes from.
Why is the third one true?
Well, do you have 2 sine of theta, cosine of thetas?
Yeah.
Okay.
But they're like
Yeah.
So if I had AB plus AB, is that 2AB? Yes.
okay.
Your brain likes to revolt when it's like not just numbers. So, all right. So that's your.
Silly. You should teach a really difficult lesson. Post no resources except for your YouTube video so that it gets a lot of
A lot of watching. All right. Okay, we're going to do the same thing for cosine. So cosine of 2 theta, that's just cosine of theta plus theta. Anybody remember the formula?
Cos, minus sine.
Yes.
Oh, no.
Yeah. Good job, guys. And what is cosine times cosine?
It's not just one.
No, if it was plus sine squared theta, it'd be 1.
Ah.
That is your cosine of double angle formula. We okay with that? Now, there are other ways you could write the cosine 2 theta formula just because of substitutions we could do. So let's just write a couple of those. Would you agree that cosine squared is 1 minus sine squared? And then I have another minus sine squared at the end here. So this is another version of it, 1 minus 2 sine squared theta. Exactly. We could do cosine squared minus 1 minus cosine squared. So if we simplify that, what do we actually end up with? Like, I don't know. Thing. Distribute your negative, and what would you end up with?
This G doesn't even go to
2 cosines.
It usually doesn't like an 8. Okay, this is like
Minus 1, no?
Yes.
Okay, I was like, what?
Yes. This one? Okay. So you're okay here, right? For the original. So I left the cosine squared alone. And instead of sine squared, I substituted the Pythagorean. So these are just manipulations of that original one. Sometimes one of these will be easier to use than the original one, so that's why it's good to know all three. And then we have one more double angle. Yep.
Tangents like division, right? There's some divide lines right.
Yeah. But it ends up not being too crazy. So again, we're doing tangent of theta plus theta. So formula from before, anybody?
That's fraction.
So it's tan over.
It's tan, but there's
the one minus.
Yeah, when it's base.
Over 1 minus.
And then it's a minus on the, yeah.
Yes. There we go. So when you simplify that, you get 2 tangent of theta over 1 minus tangent squared theta. Nope. Unfortunately. Yeah, it's kind of an unsettling formula. It doesn't look very nice. Okay, so let me show you how you would actually use these. It's a heavy sigh. All right, so first example, we'll do one of these where you're given some info.
Just the way. Will we ever do like triple end?
Nope,
It's just double and half?
double and half is the end of it, yes. No triples, nothing else.
This is bad enough.
All right, if I tell you sine of theta is 8 over 17, pi over 2 is less than theta, less than pi, we are going to find cosine of 2 theta and sine of 2 theta. When you see that given info like that, what do you know you need to do?
Try and incorporate it.
Draw a triangle. Yes, we must incorporate it, but we'll do so with a picture. Well, it's a triangle in a specific quadrant. Which quadrant should my triangle be in? Hearing, here's pi over 2, right?
Oh,
Here's
oh,
pi.
like that.
Okay.
Okay. So there is my triangle. And they tell me sine is 8 over 17. So I know opposite is 8, hypotenuse is 17. This is a Pythagorean triple. Do you guys know the other side? 15, good. Now, will that 15 be positive or negative? Okay. That's really the most common mistake made in this process, because the rest of it is just like plugging into the formula. Messing up your sign is what usually goes wrong. So just double check, look at it, and go, okay, yes, that makes sense. That one should be negative. Yes.
Is it negative because it's in quadrant 2 and going towards that side?
Yep,
Like if it
you
were
went left.
one.
Yes. Okay, so we're going to find cosine of 2 theta first. You've got a bunch of different formulas you could pick for cosine of 2 theta. You could do cosine squared minus sine squared, 1 minus 2 sine squared, 2 cosine squared minus 1. I'm going to do the 1 minus 2 sine squared just for the simplicity of the numbers a little bit. And I don't have to deal with sine and cosine then. But it doesn't matter. You could absolutely pick any of the formulas to use. Okay. Then it's just a matter of plugging in from your picture, or in this case, even just the given information. I lost my 2. Thank you. All right. So what was sine in this triangle? Yep. And now it's just, can you math? Which maybe today is questionable. I don't know. We'll see. We'll do it in steps. All right. What is 8 squared?
64.
Okay. 17 squared. 289. Okay. All right. Next piece. What is 2 times 64? Okay, and I'm going to turn this 1 into 289 over 289. So,
Yeah, it's 2 over 1.
yeah, the 64 I took times 2. Right? But not the denominator. Yeah, you'd be thinking that. Okay. Yeah, 289 minus 128. What do we get? Yep. Oh yeah, super ugly answer. But do you guys agree it's not actually that hard if you know the formula? Like it's just you're plugging in and plug and chug essentially.
If it does simplify, should we simplify?
Yeah. But this one doesn't because you know your denominator is just 17 times 17. So, all right, so that's cosine 2 theta. You guys try finding sine of 2 theta for me. You've got your formula up above. Give it a try.
Sine, beta, cosine, 2 sine, beta.
Say it again, sorry.
2 sine, beta, cosine, beta
It shouldn't matter though.
2 sine times cosine.
Yeah, 2 sine times cosine.
Let me see, I'm like not.
I don't know. I'm not first or second. 2 sine.
Yes, that's the formula.
Yeah.
Yeah, so also actually on the substitute, what is the sine theta?
Ooh, I got a 1. I got a 1. I got a 1. Got a 1.
Plug it in.
Got it.
All right, guys. Your formula is 2 sine cosine, right? No choices there. Are we disagreeing on your answers? Remember, your 2 is over 1. And guys, the order that you multiply your numerators, it doesn't matter. I don't really want to do 2 times 8 and then times 15. Like, that's harder for my brain. I'd rather do the 2 times the negative 15 and then times 8. I think that's easier. But it's whatever your brain thinks is simpler. So either way, you should get negative 240 over 289. How do we do? Well, that's not a choice, but. All right, any questions on how double angle formulas work? We're not going to do a tangent.
Thank God.
All right, let's try our half angle.
Please tell me how to reverse.
Half angle is just a little weird.
Wait a second, I was gonna eat that.
And guys, I'm just going to give you the 3 formulas for the half angle. We're not going to like derive them from anything else. So what I mean by half angle is it will be theta over 2. Like that's your angle divided by 2. That's where the half comes from. This part I know you won't like. There it is.
What in the?
Oh, there's a fraction in it. Okay.
Plus or minus, square root, fraction, lots of good stuff. It does check all the boxes.
Checks all the number boxes.
There you go.
Where's the multiplication?
I think you should, right? Are we gonna have to factor with them too?
Oh,
No.
like close-ups, like,
But like, I would understand it even if.
and then it checks all the boxes.
Decimals too.
All right, that's sine. Let's do cosine.
Oh no, just
I can't be too upset.
I did tell you you would not like it.
Well,
Don't think I was wrong.
Is it the same?
Almost. Cosine is 1 plus cosine over
That's
cosine.
cute.
Oh, dude, I'm not gonna split the difference.
That's very cute.
Wait, Mr.
It's like
Levy?
cosine,
Is that every
likes
time we work
cosine, so it's a plus, but sine is not cosine. So they're
Not with anything we'll do.
Okay, I can get behind that. I can get behind that.
Okay.
So
All right, tangent, you get a few options with.
You only use this in the real life, don't you?
I know.
You're gonna go home and you're gonna need to build a shelf.
Okay, so tangent we know is sine over cosine.
Oh, why is it big? Why is it big?
It's not really that
Yeah.
big.
Oh, you made it big, which is
Very sad.
Oh,
Don't have a
no.
measuring
Wait,
stick.
what?
What do you do?
Oh!
Isn't that essentially just sine over cosine, guys? Okay.
I forgot the one.
Now, we're not going to go through the proofs of this, but there are 2 other versions of the tangent that I'll give to you that you'll like better because they don't have plus or minuses in them or square roots.
okay.
Okay, we're excited. Sine of theta over 1 plus cosine theta, or 1 minus cosine theta over sine of theta. And that all comes from a proof using conjugates with the original ones. So they are equivalent, they look strange, but it's
Will it
conjugates.
ever matter which one, like, will there ever be an instance where you have to use one or equal always not equal plus minus
You can pretty much always pick one of the 2 that doesn't have the plus or minus for the tangent ones.
Okay.
Yeah. The first one's easier to remember because it's just the sine over cosine,
Oh, yeah.
right? Like if you know the previous 2, you know the tangent, but the other 2 are easier to work with in your problem. So. Okay.
Yeah.
Let me take it through.
Let's try them.
Okay.
Your 3-year-old son, I'm gonna have a shelf or a neighborhood. I don't care. It's a scenario.
Okay.
What's his name?
And I'm gonna call him Rohit 2.
Okay.
So Rohit 2 has needed this shelf done ASAP. And it's a very nice triangular shelf.
Why does it have to be triangular?
Now, it has to be triangular.
Why? Why would I need a triangular?
Now,
Who builds a triangular shelf?
all have no
Those are really cool.
you don't have any measurements. And
Kind of
you
minimizes what you can put on.
Am I supposed to be blind?
So,
I'm on this.
but what do you have? What are those?
What's that?
7 pi over 8. Sorry guys, the kind of line went low.
It'll be a
If
show.
you have a protractor, then you won't need it.
All right, guys. We're gonna stop building Rohit to a shelf and
But you did create a scenario where you want to.
Yeah. Maybe I should be blind.
Right?
all right, we're gonna find the sine of 7 pi over 8, and we are going to use our half angle formula for that. So guys, I'll specify on your assessment, because there'll be a few times where you're like, oh, I could find that with sum or difference formulas, and I might say, no, you have to use this one. Like, I'll tell you which way I want you to do it, now that you know more and you have options.
A time where I would use this.
Okay. So a lot of this is to get you this is like the building block into what you have to do with calculus to get to where you actually have to go. Are you going to be hanging out at home going, oh gosh, I really could use that half angle formula today. That'd make my life simpler. No, that's not going to happen. But if you skip over this stuff, the calculus part won't make sense.
Will we use the calculus stuff in our real lives?
Well, what do you want to be?
I don't know.
Oh, well then maybe. I want to leave that door open. If you're like, I want to be an engineer, but I don't think I need calculus, I would disagree with you. So, math teacher. What's the what? I'm sorry.
I'd be like a psychological physicist.
What do you mean? What are you saying, Nate? Hey guys, I can't hear the question. We're gonna find that together. Okay, so like if I asked you the sine of pi over 6, you could tell me that, right, from the unit circle? I hope you can tell me that.
I have a sign.
A half, right? Okay, so it's essentially the y coordinate if you go to that angle on the circle. So 7 pi over 8 isn't one we just know the value of, so we have to use this formula to find that. Okay.
The half angle formula? Then how do you find cosine?
Almost like a range of where your answer should be.
Yeah, so we're actually going to use the unit circle to find this. When we go through the formula, you're going to be like, oh, okay, that's where that comes. So let's write out the formula. Sine of theta over 2.
Oh, it's me. But how do you?
Okay, that's where we start. Guys, I'm going to walk you through this whole list, okay?
So I made a unit.
Oh, because that was just an example of one you know, pi over 6. Okay. We need to figure out first your little steps over here. Where is 7 pi over 8? Because that's the angle we're actually talking about here. It is in quadrant 2. Good job. Quadrant 2. 7 pi over 8, because 8 pi over 8 would be pi, right?
Oh, that's easy.
Oh, yeah. Where is 7 pi over 8? Okay. The reason we care about that, that's going to determine whether we use the plus or the minus in front of the square root. So do you think sine is positive or negative in the second quadrant? Positive. So we are picking positive. Are you with me on that? Okay. The second thing you have to figure out is what is theta? I will help you. It is.
You tell me.
I will. This 7 pi over 8, that's our theta over 2. So what is just theta? 7 pi over 4, and does that sort of ring a bell as something you know? It should. If you get to that point and you're like, yeah, great, I still don't know that angle either, you didn't do it right, okay? Your theta should be something you actually know. So we use the 7 pi over 8, which is the theta over 2, to pick positive or negative. But then, do you see in the formula here how it's just theta? Okay, that's, you're using just the theta then to evaluate this side of it. So we have positive 1 minus cosine 7 pi over 4, because that's our theta, over 2. You with me there? Then it's just simplifying and algebra and all that good stuff. So what is the cosine of 7 pi over 4? Is it positive or negative root 2? Positive, because it's in the 4th quadrant. And cosine, yes, okay.
What are the 2 points again?
For over 4s?
Yeah.
They're both root 2 over 2, just the signs depending on.
Why I think it was +2?
It's okay. All right, now lots of just, can you math? So the 1, I'm going to rewrite that as 2 over 2 minus root 2 over 2 over, I'm going to put that 2 over 1. That's still under the, I'm going to make my square root again. There we go. Yay! So dividing by 2 over 1 is the same as multiplying by 1 over 2. Let me move that up a little. Give me one, let me do the last part and then I'll go back and answer whatever we have. So I've got 2 minus root 2 over 4, but what is the square root of 4? 2. So it's square root 2 minus root 2. That is your answer. Okay, questions?
Why is this theta just 7 pi?
So this right here, the 7 pi over 8, like that the angle was given to us in the problem, that's your theta over 2. So if I solve for theta, I get 7 pi over 4. So that's why we use the 7 pi over 4 in the problem. So the formula asks for just theta. Yes, if I multiply by 2, I get 14 pi over 8 or 7 pi over 4.
You could lose again.
You see it? Was that what you're saying? Where did it come from?
How do you get from the second to last row to the red circle?
What is the square root of 4?
Oh, you just take, oh, okay.
That's all I did. When you have the square root of a fraction, it's the square root of the numerator and the square root of the denominator. Question.
I didn't see that the root got smaller. I thought it was still the whole thing.
Oh, yes, I know. I tried to make my fraction go so you could see the division there. Okay, questions? Go back up? Sure. Like there? Farther? Is that okay? Yes, we're going to do another one.
Maladaptive daydreaming really. But I am like absorbing this information.
Good, good.
It's just I'm like happy.
The video will be up for you later if needed.
I totally understand this.
Good.
Do we have math next one?
Yeah.
Don't ask me out, please.
It's the way.
I don't do it.
You don't need to do it.
I don't even do it. I've worked.
Are we okay?
Would it be negative? Yeah, I'm only working with this.
No, because we're in the 4th quadrant and cosine is the x value. So it'd be positive.
If I don't get into the Bank of America thing, then I'm gonna work at Team because Bank of America, the leadership program.
All right, guys, let's try another one. I'm going to let you try one.
It's 2 months. Like 50 hours a week or something. And then, like, there's also a
But
All right, guys, so you try this one. Cosine of 7 pi over 8. think through.
See, I have so much to do. I have to for a graphic design class. I was like, I'm going to write a whole graphic novel.
Ready, go, guys. Try this one.
You should make it about
Follow the same process.
Oh, no, I'm
Doing
doing
cosine instead of sine. Like, what do I do first? So,
It's too late now. That would be cute though. Oh,
I wrote a lot.
actually,
So you're going to use cosine of theta over 2. Write the formula.
I just like use
Decide positive or negative first, and then just evaluate your formula from there.
is like her story. So I've been researching like murder. It's really fun.
I think I have one more for you.
break at Hoffman.
Oh, and then resurrect.
Yeah.
Yeah.
And
I have 1 or 2, depending on how our timing goes. I know we only have 20 minutes left, so.
Is there a reason why you stopped writing plus minus the radical?
Yeah, you have to pick. Your very first step is pick positive or negative. We picked positive, like I circled the positive.
Oh, and then you only wrote like one.
And then I just stopped writing it because we know it's positive, but you can keep writing it.
So here.
Is
I just tell me, no, nothing wrong. I'm not saying like that. You're trying to tell me
right?
No,
What is
one step down. Like,
Woo!
Where?
Did you not write it all down?
Over 8 quarter 2, no?
Yeah.
I did. I'm just like.
Okay, come on, write the formula down.
Okay, no, it's the same but with cosine, right? So.
Plus cosine, right?
Same directions as last time. So the 7 pi over 8 is your theta over 2. Is theta over 2. Yeah.
Is it always? I can't have A push today. It's not. I'm just gonna listen to a podcast. I can't do it today.
Oscar, I like your visualization. I can see you like.
So wait, we established positive, right? So is it just like oh wait.
So guys, your first step is picking positive or negative. Did you pick positive or negative?
Negative.
Negative. Good choice. Okay, where is 7 pi over 8?
Oh. This not working. Not working.
I love that.
Is it?
Adjacent.
No.
I saw it. Wait, what is this one?
Please,
By one.
So it's in the second quadrant.
Why do you have another negative?
What's the cosine?
Because you have a negative outside there, which is there. Square root of 4 is not negative.
Okay.
If you put that there, you're actually making a fraction positive.
Oh, yeah.
Otherwise, it looks good.
Oh. All good. All good. It's all good. It's all good.
It's an answer, you know?
Look at the sound.
I'm not.
No. Where is it?
We're doing it. So it's just the inverse of the last. It's just negative zero. You know what I mean? Yeah.
Shocking development, right?
That's crazy. That's so cool.
Dividing by 2 is the same as listed.
No, they lost.
In the denominator, the negative, here's this negative. That's still there. Taking the square root of 4 is just 2. Like, it doesn't create another negative. If you put a negative in the denominator, you turn the whole fraction positive.
Oh, so basically you just keep the negative in the numerator.
Yeah, like, let's say I had negative, we'll do it with numbers, like,
Yeah, but like it's not like this.
Yeah, I understand.
that's negative root 5 over 2, right?
Like algebra with the
So it's
Right over here, like, that's not, you're not going to put another negative in that denominator, right?
Oh, yeah.
You see it? Okay. Yes.
What is that negative 5? Negative 5?
Absolutely.
All I have is
Nothing.
Oh.
That was just answering his question. You're fine. Just going back to all numbers, see if it makes sense.
Oh, yeah.
All right, guys. Any questions on number 3?
No, it's fine. I'm like, how long? I should. I know.
Okay, let's try again. Again? No. Let's do another one of these given ones where I give you information. I like them. It's where you have to draw the triangle. Oh, you like it less?
How much space does this take up?
Almost half a page. Depends on how big you write.
Wait, this one's like
I mean, I space my stuff out, so I don't know.
how long is this? Is it gonna be just like the last given one? Like as long as that one?
Pretty much.
We're gonna have to cry a little bit.
I guess I should ask you something. Okay. So this is obviously a different setup than the last one. We're going to draw our picture. That's what you always do first with your given ones. What quadrant am I drawing in? Okay. All right, sine is 5/13, so opposite is 5, hypotenuse is 13. What's that other side of my triangle going to be? Okay, negative 12, right? All right, let's write out our formula for cosine of theta over 2. Plus or minus big square root 1 plus cosine theta over 2. Okay. Where is theta over 2? That's what you have to start with on this to figure out your plus or minus. Because your picture, this is just theta, right? Okay, I need to figure out theta over 2. I need to figure out half of this. So, a few ways you can go about that. I'm actually just going to go in here and divide everything by 2 to tell me where it is, because that will create a theta over 2. here, right? I want to know where is theta over 2, so I'll divide all of these by 2. What quadrant am I talking about now? First. Now, another way you could think about it, everybody sees theta's originally in the second quadrant, right? You could just, in your head, pick any angle in the second quadrant. I could say like 100 degrees. That would work too. And just think about what that divided by 2 is, and what quadrant does that end up in. So if I start with 100 degrees, divided by 2 is 50, I know theta over 2 is in the first quadrant. Okay? So right, theta is in this second quadrant right here, yes? I can pick any angle from the second quadrant. I can pick 160 degrees.
Oh, okay.
I'm saying, like, let's pretend that's theta. So theta over 2 then would have to be 80 degrees, which is in the first quadrant. We don't really care what theta and theta over 2 are specifically. We just care where are they, which quadrant are they located in. Okay, so whichever of those ways makes the most sense to you, that's fine.
Wait, sorry, how is it on the first one? Using like the divide by 2.
Pi over 2 over 2 is pi over 4. So between pi over 4 and pi over 2, isn't that the first quadrant? Remember pi over 2 is up here?
But if you divide something by 1/2, isn't that the same as multiplying times 2?
I'm not dividing by 1/2, I'm dividing by 2, which is the same as multiplying. Yeah. Okay, the whole reason we had to figure out where is theta over 2 is to pick the plus or minus in front of our formula. So, what am I picking? Positive, yeah. If theta over 2 is in the first quadrant, I don't care if it's sine or cosine, it's going to be positive. So, plus, and then it's just a matter of using the formula. 1 plus. Okay, now we're back to just theta, though. It says cosine of theta. Look at your triangle. What is the cosine of theta? Negative 12 over 13 over 2. And then it's just mapping from there. Do you guys see the difference between finding theta over 2 to get the plus or minus, using theta in the formula? Like, those are 2 different things. Okay. So, just simplifying here, this is going to be 13 over 13 minus 12 over 13. And then divided by 2, are we okay with times 1/2? Can I just do that? Yes.
How did you get the negative 12 over 13?
I looked at my triangle.
That's the second one.
This says cosine of theta, right? There's theta. Do you see the difference? That's the hardest part here. You've got a theta over 2 you're dealing with and a theta. The theta's in the formula, and that's from your triangle.
Are you just saying that because?
Yeah. Where is theta over 2?
Okay, so you have to focus on the theta over 2 when you're picking the sine.
Yep. Theta over 2 is for picking sine. Okay.
You're so wrong.
And then theta is for formula. Pretty much, yeah. I have one more to practice, but does that make sense, Jane?
Yeah.
Okay.
So we never should get.
All right, so simplifying this, 13 minus 12, I've got 1/13 times 1/2. I get 1 over 26. I need to rationalize that, so what is it going to be?
It's great.
Right? Root 26 over 26 when you rationalize?
Yeah.
Ah.
Yeah.
Ah.
Yes.
Yes.
Oh.
We got it. I
Yeah.
agree.
Oh, I'm not.
All right, guys, I'm going to put one more up here. We'll see if we have time to get through it. Same idea. You'll be given info here, draw your triangle, just so you guys can try one. All right, guys, try this one. I'll get your math space open while you're trying it. Tangent.
Oh shit, they over 2. Yeah, they over 2.
Oh, it's not plus or oh, it is.
How's your triangle drawing going, guys?
Great.
What quadrant is it in to begin with? Okay. Where is theta over 2?
Oh,
Second, yes, quadrant 2. So what does that make tangent of theta over 2? Are you picking positive or negative? Negative. And then that really only matters if you use the first formula. You're welcome to use one of the other two formulas where you don't actually have to pick the plus or the minus. It is up to you. Did you guys pick one of the other ones? Yeah.
Do you get an I by chance? Or is
You do not. I'm going to use. You do.
I did.
I'll try this one.
But we're just not going to do the original. So
Yeah, pick the non-square root one. Why not, right?
yeah, that's the script. But I did.
Because then it doesn't even, this part doesn't even matter then.
Yeah. That's just not a good time.
It's fair. Did you get -3?
Yeah, I haven't finished it.
I did it way after you.
Well, that is true, actually. Just,
It's okay. I use the non-square root formulas, which makes it a little bit easier, so.
maybe I should use my glasses. Like, I can't tell what's at 3 against 2.
Oh dear, that's not good.
It's 5 over 3.
So this was, I turned the 1 into 5 over 5.
Oh, oh my god.
There is math space somewhere, guys. It is posted. I'll post the second attempt today too, so it's there. Guys, I'll try to get your Delta Math review up today as well. What? No food in Warhawk time today.
20 seconds.
Wait, what? There's no Warhawk time in it?
No.
You said, is there food in
Yeah,
Warhawk
but
time? And I
you
said,
there's
no food in Warhawk.
We definitely haven't.
All I heard
Yeah,
was,
probably.
all I heard was,
20
oh,
seconds.
like Warhawk time, and I was like, oh, God.
Shut out the rest of what I'm saying.
I think I'd be okay.